This is the unit review for Unit 4, Activity 19. We're going to be focusing on exponent rules today. Specifically, we are going to use properties of exponents to transform expressions, and we are going to transform exponential functions involving integer exponents. Our product rule is our first review rule. And whenever your bases are the same, so see my bases are the same here, I'm going to add my exponents. So here on our example, we have x squared times x to the 6th power. The first thing we notice is that our bases, our x's are the same, so we can add our exponents. So 2 plus 6 gives us a base that stays the same, x, and then an exponent of 8. All right, our power rule is when you have a power raised to a power. Here you can just multiply your exponents. So here I have this power to a power. So this 2 basically gets taken or given to everything inside the parentheses as an exponent. And if there's already an exponent there, we multiply the exponent. So I end up with 3 squared and then x cubed squared, which again I can multiply those exponents and get x to the 6th. And then I can clean that up a little bit further because I know 3 squared is 9. So I have 9x to the 6th as my final answer. Okay, next we have the quotient rule, which is division. So when your bases are the same and they are being divided, you can subtract your exponents. So looking over here at our example, we have our 2 coefficients, 45 and 9. We can go ahead and divide those just like normal constants. 45 divided by 9 would give us 5. And then we have x to the 5th over x cubed. So the bases are the same, so we can subtract those exponents. 5 minus 3 gives me an exponent of 2. So my base stays the same, and then I have 5x squared. Negative exponent rules. Remember, your negative exponent basically flips. So if it was on top, it goes to the bottom and the exponent is now positive. If it was on bottom, it goes to the top and the exponent is now positive. So over here on our example, the only thing being raised to a negative exponent is the x. So the 4 is not raised to this negative exponent. It's important to recognize that if there were parentheses here, it would be different, but there's no parentheses. So the 4 is actually going to stay on the top. And then the negative exponent here takes this x to the bottom, and the exponent now is positive. So 4 over x squared. The zero exponent rule says anything raised to a 0 power is 1. So again, similar idea here. It's important to recognize that what we're given is not the same thing as this, because this would mean everything here is being raised to that negative or that 0 exponent, which would mean this whole thing would go to a 1. But what we're given is just this x being raised to the 0 power. So x to the 0 power would be a 1. The 6 is still there. Now there's a 1 next to it, and of course 6 times 1 is just 6. So it's good to see that contrast there with the parentheses, because the parentheses do make a pretty big difference. Okay, we have a few more examples to work together here. Looking at number 1, it is 2x to the 5th times 5x to the 4th. If you would like to pause the video, try that one on your own, and then come back when you're ready to compare answers. That might be best. So I'm going to multiply my coefficients. 2 and 5 give me 10. X to the 5th times x to the 4th. My bases are the same, so I can add my exponents, x to the 9th. All right, number 2, if you want to pause the video and try that one on your own, remember you're using your quotient rule. Okay, so the 2 is just going to stay. X to the 5th divided by x gives me x to the 4th. Y to the 4th over y squared gives me y squared. All right, looking at number 3, if you want to pause the video, try that one on your own, see how far you can get. Looking at number 3, these are being multiplied, so I'm going to multiply my bases. 2 times 5 gives me 10. And then I have a squared times a, which is going to give me a cubed, because remember there's an imaginary 1 here and here as an exponent. And then b to the negative 3 times b to the 1. So again, my bases are the same, b, and I'm going to add these exponents. Negative 3 and 1 give me a negative 2. So when I have b to the negative 2, I know that I'm not finished simplifying yet, because the 10a cubed is going to stay on top, and this b to the negative exponent is going to go to the bottom and then become a positive exponent. So on the bottom, I should have b squared. So 10a cubed over b squared. All right, number 4, go ahead and pause it, see what you can come up with. All right, looking at number 4, this 2 exponent needs to be distributed to everything inside the parentheses. So I have a 5 squared, which is 25. I have an x squared, a y to the 8th. Remember, to a power means you multiply. So I have a 1 times 2 giving me a 2 exponent, a 4 times 2 giving me an 8 exponent. Same thing on the bottom. 3 times 2 gives me a 6 exponent. Now I can clean this up a little bit more because I have the quotient rule coming into play here. I still have my 25x squared, and then y to the 8th over y to the 6th, same base. I can subtract my exponents and get y squared. Okay, so at this point, if you would like to go ahead and do the independent practice, and then of course I'll post the key for you to compare your answers to. That concludes your Activity 19 video.